Thanks for joining us today. This is the second session of the Innovator Island series, where we'll be building a serverless web application for a theme park. My name is James Bezic. I'm a developer advocate here in the AWS Serverless team. I was formerly a product manager and a software developer for many years before this. Now, the most important thing on this slide is my email address and my Twitter handle. So if you have any questions at all about this workshop or serverless in general, please feel free to reach out to me, and I'll do my very best to help. So previously in the last session, we set up Cloud9. We also deployed a backend, and then we deployed a front-end application using Amplify Console. So we've got a public URL with our front end running on it. The goal of this whole process is to learn how to use a range of different AWS services to build a real-time web application. All of the code is provided for you, so you don't need to write any code in these sessions. Also, today we'll be looking at real-time messaging. That's the focus of this session. And so you probably use websites all day that use this particular pattern. And in this app, we have a ride system that publishes ride times out to a system that then we want to integrate with our front end. So our visitors can look on our app and see what the wait times are for different rides throughout our theme park. So there's different tools and services we're going to be talking about today, including WebSockets and also the publish-subscribe pattern as opposed to query and response, typically used by APIs. We'll be talking about the MQTT protocol, SNS, IoT Core, and why this all fits really well with single-page application frameworks like Vue.js. So we've got a lot to cover in this session. Most of this session will be doing the workshop, and I'll be doing this side by side. So I have the instructions and my console on the right hand side so you can see exactly what I'm doing. Just a reminder of a few of the prerequisites and housekeeping of these sessions. You'll need to have an AWS account, so if you don't have one, you can sign up at aws.amazon.com. You need to be using one of the supported regions for the workshop, and that's shown in the instructions, and we'll see that in a little bit. Also, let's talk about cost. So although the workshop's totally free and you can follow along at no cost, running some of the steps may incur small charges. For most people, it should be doable within the free tier though. To take part in today's activities, you're going to need a laptop or a desktop computer, not a tablet. And we want to use the Chrome or Firefox browser for optimal compatibility. We're going to be building serverless applications using a wide range of different services, including Lambda, API Gateway, DynamoDB, just to name a few. So existing familiarity with the AWS Management Console is helpful, but it's not essential. Today continues from the first session, so if you've not seen that, you should pause here and go back to the first video just to catch up to set up everything we need for today. Remember, the goal is to get you through this workshop, so if you have any questions at all, please don't hesitate to contact me. All of the code and the instructions and everything you need is at this URL on the screen, s12d.com/island workshop. So let's talk about where we are in our process so far. So in session 2, we're talking about ride wait times. So a major part of the app is showing guests how long the wait times are throughout the theme park. So we have a system called the Flow and Traffic Controller, and that monitors how many people are in line at different parts throughout the park. This is a separate system to anything we're building. So what we want to do is connect to this system and set up the backend so it can publish these live wait times through to the front end app. So this is what we're going to be doing throughout this entire session. So how does this work? Well, the system publishes to an SNS topic. And so we're going to create a Lambda function that's invoked by this SNS topic. And don't worry, we have all the code available. It will then update an IoT topic with new ride wait times. And then the main configuration table will be held in DynamoDB. So the front end listens to this IoT topic via a WebSocket connection, so the ride times are shown in the map in real time. So after this section, you'll have a real-time front-end application. Okay, so let's get started. Everything we need for this session is at this URL, s12d.com/island workshop. So I'm continuing on from the first video where we left off, and it'll be the same thing. I'll split the screen, so we've got instructions on the left-hand side, and I've got the work that I'm doing on the right-hand side, so you can see step by step where we are. Currently, this is the state of the application, so you can see where we left it off before, that we've got rides appearing on the map, but we don't have any wait times or information yet. So by the end of this module, we'll have real-time wait times appearing on these rides as well. So let's first get to this instructions page. That's also at that link s12d.com/island workshops. If you just go to that link there and then go to the second module, that's where we'll be starting for this session. Now also you want to make sure you have Cloud9 running. So to get that far, just go to any page within the AWS Management Console, search for Cloud9 in the services dropdown, and from there you'll be able to find your IDE and just click Open IDE. It can take a couple of minutes to get started, so if you need to pause the video, just pause the video and I'll wait for you. Once your Cloud9 instance is running, it'll look something like this. So just like last time, you have your files on the left-hand side that we've already downloaded in the first module. We have the editor at the top, and we've got the terminal at the bottom. So I'll be entering my commands in that terminal as we go through the steps. So in this session, we're going to connect real-time data to the front-end application. So let's get started with these instructions. So in the theme park, we've got a service called the Flow and Traffic Controller. This collects ride times from the physical rides, and it publishes these ride times once a minute into the infrastructure. So we're going to connect that with this front-end application. So how does this work? Well, the controller that we have publishes these updates once per minute to an Amazon SNS topic. Now this has already been created as part of the work that you did in Module 1. That SAM template deployed this system already. So in this module, we're going to create a Lambda function that's invoked every single time one of these messages arrives in SNS. This function is going to store that message in DynamoDB and also forward the message to IoT Core. After doing that, we'll make the updates to the front-end application so it can listen to this IoT endpoint and then republish the front end so everything is live. So this module introduces two new AWS services, Amazon SNS and AWS IoT Core. If you want to learn more about either one of these services, just click this link in the instructions and there's plenty of information just there. The infrastructure we're going to be building looks like this. Essentially, here's the SNS topic that already exists. This is the Lambda function we're going to build, and this will talk to a DynamoDB table that already exists and this IoT topic. So this flow and traffic controller already exists, so we don't need to worry about that. And really we're looking at this, the first step is to create the Lambda function. Now, why do we need the DynamoDB table? This is an interesting question. So with the IoT topic, that'll be publishing real-time updates to a connected front end when it's listening. But the DynamoDB table will be there to store the last known set of values. So if somebody comes along and starts the front end in between receiving an update, they'll be able to see the latest time. So really that gives us the state of the world in the state of those rides right now. So let's look at the very first step of setting up the back end. So first of all, let's set up these environment variables. If you're continuing on from the first module straight away, you don't really need to do this because we did this before. But if you've left it a few hours or you're coming back on another day, we're just reminding the terminal what these variables are. So I'll just paste that in, and that just updates those environment variables. Okay, so first step is to create a Lambda function. So in step one, let's go to the Lambda console. To do that, I go to any AWS page that I may already be in there for, and just click on or type in Lambda in the service list, and then click on that. That will take us to the Lambda console. Now, of course, you want to make sure you're using the same region that you were using in Module 1. Just make sure you haven't accidentally changed the regions. So from there in the drop down, I'm still in US East 1, that's where I was in the previous session, so that's fine, but just make sure that's the case, otherwise you might get strange results when you deploy things. So first of all, step number 2, we're going to create a function. So on this page, click Create Function. We're going to choose author from scratch, that's the default. And then down in basic information, we're going to use the name Theme Park Ride Times. I'll copy and paste this. If you type this in, just make sure you have the dashes so that the names match exactly the same way. We're going to use Node.js 14 for this runtime. That's already pre-selected. If it's not in your case, just click on the drop down and select it. And then we need to change the execution role. So we'll open this section called Change Default Execution Role. I'll select the Use an Existing Role button. And then in the existing role drop down, I'll click this. And I have quite a few roles, but I'm looking for this one called Theme Park Lambda Role, and click that. Yours will have a different ending to the name because it's unique to each account, but otherwise this main name will be the same. So this now matches the screenshot shown in the instructions here. And when you get this far, just click on Create Function. This just takes a couple of seconds to then create the Lambda function. Now currently this Lambda function doesn't have anything invoking it. It's a brand new function. It doesn't do very much at the moment. So the first thing we want to do is connect it to that SNS topic so that it will be invoked. So in step 4, we want to click Add Trigger. And then in step 5, click on the trigger configuration drop down and choose SNS. You can choose it manually or just type it from the list to match until you find that. So in the topic selector, we want to find the SNS topic starting with this name, Theme Park Ride Times. Now typically you'll only have a couple of SNS topics if this is a new account, it may be only one. But just make sure that you're selecting the one that matches this. So we've got the Theme Park Ride Times topic just there. When you select it, it'll populate this field with the entire ARN. That's the Amazon resource name. So now my Add Trigger view looks a lot like the instructions. So on step 6, it tells us to leave the Enable Trigger checked. That's a default anyway. And then click on Add. So I'll now click Add to create this trigger for the Lambda function. Now back in the function view, you've got multiple tabs across the top here. We're currently on the configuration tab, so click on the Code tab to open the code source panel as shown here. Now what we want to do is copy across the code that is used for this particular feature. I've done this already, so I'll take away this and delete that. And if I go back to Cloud9 in step 8, in the left-hand directory panel, I want to navigate to Theme Park Backend 2-realtime app.js. So I'll just open this. And if I double-click app.js, that shows us all the code that we want to use for this Lambda function. So double-click the file as I did there, and then copy the contents to the clipboard. So I'll just select everything and then copy it. In step 9, we go back to the browser tab within the Lambda console. If you close this down, don't worry, just go back to the Lambda console, go to the list of functions, and then you'll find ride times. If you search for ride times here, you can find this function and then just open it there. And that's fine. Just make sure you're on the code tab so you can see the code source window. Now I've copied the code to my clipboard, and I just want to open this and paste in this new code so we can update the code within this Lambda function. I'll paste that code in there. And you just want to make sure you overwrite what was there already. So previously there was an empty Lambda handler. This is the Lambda handler that we want to use. So now, step 10, we will click the deploy button. Currently this is not deployed, so it's just existing in the browser, but once I click deploy, that will then publish this function. And you can see there then the changes are deployed. So let's take a quick look at this code before we go any further. I'll do it inside Cloud9 because it might be a bit easier to see. So remember, this function is going to do two things. It's going to publish the latest message to a DynamoDB table, but also to an IoT topic. So if I scroll down to the handler, that's this part here. First of all, it's extracting the message from the SNS event that's passed in to this handler in this event parameter here. It's also then logging out the message. So if you look at any of the logs for this function, you'll see this from SNS log message with a copy of the message from the event. Now each time it's then going to call save to DynamoDB and then IoT publish. So what do these functions do? Well, save to DynamoDB calls the put method using the document client to save that message to DynamoDB. Uses one line of code to do this. And then IoT publish is using the publish method of the IoT data SDK to publish this message to that topic. And the topic is specified a bit further up. There we go. It's taking it from an environment variable that we'll be configuring shortly. So what's interesting here is you can do these things using just one line of code. You can publish to both DynamoDB and to IoT Core using these one-liners. So it doesn't take much custom code to make these integrations work. Okay, so I'll go back to the instructions. So we're back on step 10 where we deployed this. And then what we need to do now is add these environment variables. So this code is making reference to some of these. You'll see these in process env IoT topic. Anytime you see process env, it's using something that's not in the code itself. Environment variables are really useful for passing things into code that are stack dependent. So when you deployed that SAM template, you were deploying code that will create DynamoDB tables and other resources that have different names depending on your account. So the code doesn't know what that is at the point where the code was written, so we can pass those in using environment variables. Now this function uses three environment variables: IoT data endpoint, IoT topic, and DynamoDB table name. So what we'll do is we'll fetch the values and then we'll add them to the Lambda function. So at step 1, we're going back to the Cloud9 instance. I'll just clear this. And we will then I'll go to the terminal and find the value for IoT data endpoint. This was already deployed as part of the stack in module 1, so I'm going to just copy this command and run this, and this will return the endpoint address. Let's just copy this down. If you still have your scratchpad from yesterday, we can also make a note of this. It's a useful thing to know, so I'll just copy that down there. Next, we're going to take in step 3, we're going to get the DynamoDB table name. So this CLI command lists all tables that you have in DynamoDB, and it just greps for the one containing the word backend. So otherwise it would list absolutely every table. So by doing that, you can see this now has returned that table name. I'm going to just take a note of this as well, just in our scratchpad. So in step 4, we want to go back to the browser tab containing that Lambda function, the theme park ride times Lambda function. So we can see where that's the Lambda function there. And then we need to choose the configuration tab. And then just select environment variables on the left, just there. All of the metadata for your function is in this configuration tab down on the left-hand side once you go to this menu here. So to add an environment variable, we just need to click Edit here. So that's step 5. Choose Edit on the environment variables card. Now currently this doesn't have any environment variables configured, so let's set up those 3 variables. If you click Add environment variable 3 times, it'll create 3 boxes for the different key value combinations. Now it doesn't matter which order you enter these in, just make sure when you put them in there they don't contain any spaces. So each time I paste those in, I just have to erase that last space. The IoT topic is this fixed value, so we can copy that across. And then the DynamoDB table name, we took a note of this, so that's that value just here. Copy that and paste that over to this field. And then the IoT data endpoint is this endpoint just here. So I'll copy that and then paste that over to there. You'll see that my window here looks a lot like the screenshot. Hopefully yours does too. Again, the order of the values doesn't actually matter as long as the values are there. Now once you've put those in, step 7, choose Save. So just take a note of the warning down here that if you've accidentally selected the tags window instead and entered them there, this won't work. So the UIs are very similar, so just make sure that you have selected the environment variables window just there. Once you've chosen Save, you'll see that these have been updated in this display, and you can see each one of the 3 values. Now what we can do at this point, this isn't in the instructions, but I'll just show you what's happened. We're receiving messages already from SNS every minute because we connected that trigger a while back. And if I look at the Monitor tab, I can take a look in CloudWatch logs and see what's happening. So let's take a look at what's happening in those log files. Now remember, when we looked at the code, there was a console log line that was just logging out the event as it was receiving them. So actually every minute or so you can see there's a different log stream that's been created. Let's take a look at the most recent one to see what's happened. If I open up this, you can see that this is one of the messages that's been received, and it's a list of rides along with their wait times. So these are all in service, and these are different wait times in minutes. And so that message has been successfully received by this function several times just while we've been going through making these changes. So we can see that we are successfully publishing out these ride times through to IoT Core and saving them in the DynamoDB table with these changes that we've just made. Okay, so back to the instructions. I'll close that window and then we can go on to the next section. So that was the backend section that's now been completed. Okay, so now we're looking at the front end. So to enable the front end to listen to the IoT topic, that's where we're currently publishing these ride times, we need these 2 values, the IoT endpoint hostname and the Cognito identity pool ID. So why do you need Cognito? Well, an IoT endpoint is a resource like any other, and we want to secure this resource. Now we can secure it for both authorized and unauthorized users, and I'll cover this a little bit later once we go through this module, and I'll go through in detail what is happening there. But for now, just note that we do need a pool ID to be able to make the connection to the IoT endpoint. So what we're going to do is make these changes as it says here, and then we'll then commit this change to the Git repo, and that will automatically republish the application using Amplify Console. So let's do this. We're in the step-by-step instructions. We'll go back to our Cloud9 instance. It's running in this tab. Make sure you're still in the same region, and then we're going to run this command to show the identity pool ID. So I'll just copy this. I'll clear here so you can see this more clearly, and we'll run this. So I've got one identity pool called Theme Park Identity Pool, and that there is the pool ID. So I'm going to copy that value. I'm going to put it in my scratch pad just for safekeeping in case we need it later. And we're going to take a note of that. So the next one, step 3, is to get the IoT endpoint hostname. So I'll run this command. Each of these is using the AWS CLI to be able to query this information. You could get all of this through the console, but it's more useful to be able to use the CLI for these sorts of interactions. So we'll copy that endpoint address. And again, I'll note it in my scratch pad. It's a useful value to keep down. And then we'll just make sure that we know what our region is. So remember, we set up this AWS region variable, and it says we're in US East 1. So that's not something that normally exists in Cloud9. We just defined it in our first module and refreshed it actually earlier on in this session too. So those are the 3 values that we need to be able to then connect up the front end to this back end. So in step 5, we're going to look in this left directory panel and navigate to theme park front end, that's there, in this src folder. So that's there. And then in step 6, we're locating config.js. Now remember, config.js is where we have all the user-defined configuration values for the front end. It's the only file you need to change in the front end during this workshop. So module 2 is commented just here, and you can see the 3 values. So here we are in step 7, and it wants us to update those 3 values. So we're setting pool ID to the identity pool ID, the host to the IoT endpoint hostname, and the region to the AWS region value that we outputted there. So I can do this one first, that's the easiest, US East one. Now the pool ID, I took a note, is this value. So I'll paste that in. Now you want to note that it follows this kind of format. If the value you're pasting is not following that, it's probably not the right value. So just double check when you put this in that that's the value you expect. And then the host is this endpoint value. I'm going to just copy that and we'll just paste that into this config just there. And again, it follows the if we saw the comment there, but it follows the same format there. Okay, so step 8 is to save the file. Very important. So remember in Cloud9, when you have an unsaved file, you see a little ball icon next to the file name at the top. That's the cue that the file hasn't been saved. So I'm going to save this with Control S. Once it's been saved, the little ball icon disappears. So we've made a change. We've got one file that's now been changed. And to show you this, it's not in the instructions, but I can do a git status. And that shows me this one file that we've modified. The zip file is not part of the repo, so don't worry about that one. So in step 1, we're going to then cd into the front end directory. You might already be there, but this just helps make sure we're in the same place. And then we're going to run these 2 commands to commit the repos. So git commit -am. We're using a comment module 2. You could use any comment you preferred. And then git push. So this is very fast because it's only a very small change to the repo. So step 3, after this commit is completed, go to Amplify Console. You can click that link there, or you can do this from any of the pages you have open in the AWS Management Console. Just type in Amplify, and then I've opened this in a new tab, and you'll see this one app that we defined already, and you'll note that this is running. How is that? Well, if I click on this, you'll notice that it's already started the build. You can see the provision check mark is checked, and then these other check marks it's working on. So Amplify Console is listening for changes in that code commit repo. So every time we do a push, this will happen automatically. There's nothing more that we need to do. And this is a really useful feature because when you're publishing production applications, you want your existing users to continue using an old version that's at the same URL, then automatically be switched over to the new version when you push that out. But if there are any problems here, like this build fails for some reason, Amplify Console is smart enough to not remove the old version, so any of our users who are currently using the software will continue to use the deployed version and will be unaware that there was a build that failed. But hopefully this continues and it will pass, and then once it does pass, it will then be deployed to that same URL that we've been using over here. So it's this URL just here. Remember, if you're looking for the URL where the application is published, it's published just underneath this icon just there. So that's your link. So you can always just click that and it will open up the latest version. I'm going to use this window just because I've set up my console in the way that I want to see this. So this just takes a couple of minutes to complete building the application. Now if you had a real production application, you can put pretty complicated build settings into Amplify Console, and it will run these every time that it finds a change in the GitHub repo, and will run a complete build script, pull all the dependencies it needs, and run any tests that you need as well. Right now our build script is fairly simple for this workshop, so it shouldn't take too long. Okay, so that just went green, and so that now has been built. and it's now deployed that to that URL. And at the very end, it's going to verify that this deployment looks good. So we'll wait till this very final checkbox is completed, and usually that's pretty fast too. So once your deployment goes green over here, you just go to that endpoint. Now, currently we're looking at the old version where there were no ride times. So what I'm going to do now is I'm going to do a hard refresh in my browser by pressing Ctrl F5 to load the new version. So this is step 5 just here in the instructions. And that now is completed over there. So I'll press Ctrl F5, and that will do a complete refresh of the application so the browser's not caching anything. And you'll notice immediately what's different here is we've got these times that have appeared within the application itself. So not only do we see the names of the app, of the ride, we also now see wait times. So what is different in the output here, you'll notice, is that it's now getting those credentials from Cognito at the beginning when the application starts up. It's forming a connection with the MQTT client, which is forming this WebSocket connection to this topic on IoT Core. And I think you just saw a message appear just a few seconds ago. Every time that ride wait time is published to the SNS topic, that's now being picked up by the Lambda function and being published to the IoT topic. And then thanks to that connection we have, you'll see that these messages are appearing just here. And that's actually the same message we saw in the CloudWatch logs when we took a look at those earlier in the function. So once a minute in this console area, you'll see these appearing. You just saw another message just appear just there. So that concludes this part of the workshop, but I wanted to spend a few minutes going through some of the details about how this real-time connection works. Okay, so that's module 2, but let's talk a little bit about how you get data to and from front-end and back-end applications. So there are a few different ways of doing this, and I think it's worth just reviewing a few of the common ones that are used in applications that are hosted on AWS. So the first 4 use API Gateway, and there's 4 different common modes. The first one is the synchronous request and response. We did this already in module 1, where the application makes a request to an API Gateway endpoint to receive a payload of data. In this case, we've got rides that we use to populate on the map. Now this approach is fine for fetching data. It doesn't change frequently, and it puts the client in control of fetching and receiving that information. However, it's not good for real-time information because the client simply has no idea that something has changed. So version 2, API Gateway with WebSockets, can alleviate some of that. If you make a request to API Gateway for something, but want to continue to receive information, the WebSocket mode of API Gateway can help you with this. This is generally pretty good when you just have one piece of information, a topic, or something you're subscribing to that you want to receive updates on. The third method is an asynchronous request with polling. So if you imagine a long-lived request, so something longer than just fetching a list of rides, imagine a payment process or something of that nature where it takes a few seconds or minutes to complete. You might have something where you make a request to a backend, such as finding a driver on a service like Lyft or Uber, for example, and the backend goes away and does that work asynchronously. So in this case, it responds back to the front end saying the work is in queue, being worked on, but the two are now disconnected. And so in this case, the front end then polls periodically to see if the work has been completed, and it will keep polling until it gets an indicator that the work is done. In the fourth case, you have an asynchronous request with webhooks. This is similar, except that the front end would not be polling. The back end would have an HTTP or HTTPS endpoint it would call when the work is done. This can work for some types of front end, but not others. It depends on what framework you're using. And then the fifth case is what we're using in this workshop. This is using IoT Core. Now, under the covers, what's actually happening here is you've got a real-time publish-subscribe connection that uses MQTT. And the way this works is that there's a topic that bridges the front end and the back end so that the two sides know what they're talking about. And I'll explain this in a bit more detail. So in a publish-subscribe connection, you have a publisher on the left and subscribers on the right. The two don't necessarily need to know about each other. It's a decoupled way of passing information. So in the pub/sub model, a subscriber registers interest using topics, and the publisher publishes to those topics. So the topic can then fan out to many subscribers, or it could just have one subscriber, and the subscriber could subscribe to many topics or just one topic. It's entirely optional. So in many web applications, you have a combination of this type of setup where you could have account level information with one subscriber. So for example, for information like you've been logged out, or a broadcast level topic involving many subscribers, and that's for common subjects of interest, commonly used in things like chat rooms, but also used in this example. So the publisher in Innovator Island is publishing ride wait times to one topic, but there are up to 50,000 people listening to that topic to get those ride wait times. Or you could have an all users topic. This is something that affects everybody who's using the app. That might include things like emergencies or outages of that kind of nature. So the important thing about using this is that pub/sub in this particular implementation is forward-looking from the point of the connection. So in the case of the Innovator Island front end, it connects to the IoT Core topic, but it only gets information from that point of connection. It doesn't get any history. So there's no catch-up. There's nothing happening to tell the front end what happened before it connected. And so one of the ways we get around that in this type of application is to use a DynamoDB table to keep the latest record of what it knows, so that when the application first connects and it makes that request for the API gateway endpoint with the list of the rides, that's also returning the list of the latest ride wait times. So that's one way to get around that issue of only being able to look forward when you make this kind of connection. So IoT Core is a pub/sub routing mechanism that we're using to connect publishers and subscribers. And it can work with a very large list of subscribers. It's extremely scalable. It also provides cost-efficient messaging. So if you have lots of messages on this type of system, this is a good way to do it. IoT Core is serverless, so as your number of subscribers grows, you don't need to manage any sort of infrastructure or fleet of servers to manage that as it grows. It simply happens automatically. So the AWS SDK is the way that we connect these two sides, and you've seen some of the code so far on the back end. So on the left hand side, the IoT data.publish method, that takes a topic, a quality of service measure, and also a payload, which is the actual message. And that one line publishes that information to IoT Core. Now the front end on the other side, we've not looked at the front end code in much detail, but this is what happens on that side. That's actually listening to this MQTT client, and when a message is published and it's received, it picks this up, and this handler then takes a topic and a payload. Now in our case, we're just listening to one topic for theme park rides and then processing the payload. But potentially you could be listening to lots of different topics and taking all sorts of action depending on what you need to do in your front end just there. So the most important thing when you're designing web apps this way is to decide on your topic structure, and then your publisher uses the code in blue on the left hand side there, and then your subscriber uses code that's similar to what's in green on the right hand side there. So in the SAM deployment of the backend, the template that specifies how this is deployed, it deploys an IoT thing, but also a Cognito user pool. And so IoT things are AWS resources just like any other. And so we want to set these up and secure them. In the template YAML, you have the IoT thing, which is the application level resource for the whole theme park app. And then there's a user pool client, and an identity pool. And it uses the defaults here, and they're the same as if you set them up in the console. The app uses two roles. You have an authenticated and an unauthenticated role here. Now the workshop does not use any form of authentication, so we've allowed unauthenticated users to access the topics with a read-only mode. In production systems, you might have some messages for unauthenticated users, things that are generally known like ride wait times or stock prices or something of that nature, but you may have other messages that are restricted just to authorized users, such as bank balances or shopping cart history or that kind of thing. So this shows how you can secure the messages for both authenticated users and unauthenticated users. Just look in the SAM template for more information. Okay, so today we implemented a real-time messaging system for the web application. And we went through the whole of that module. And we showed how to connect data from an SNS topic all the way through to an IoT topic using a Lambda function. We covered how this data is subscribed in the front-end app, and we also talked about publish subscribe as a pattern and using IoT Core to implement this for a serverless web app solution. So in the next session, we'll be going through looking at photo processing. So if you want to continue on with that just now, don't close down your Cloud9 instance or any of your tabs, and we'll pick up straight up where we left off. If you do want to close down, don't worry. I'll show you on the next session how you can restart your Cloud9 instance. Thanks very much for joining me on this video, and I'll see you the next time.